Now, let us get hands dirty and look into some practical aspects when using the discrete element method to solve a practical problem. Of course, we need to use a specific software. However, all the basics you're gonna learn in this unit are the basic principles behind every DEM tool that exists.
Welcome to this unit on practical aspects of the discrete element method. Let us start with what you will learn in this unit. First, I would like to make you familiar with the input that needs to be provided to a typical DEM simulator. Next, I would like to show you how one then performs a simulation with two different phases in the simulation. Specifically, we will fill a hopper and then empty it. The reason why we do that is to enable students to be able to restart a simulation after, for example, a filling phase. Next, we will apply rules of good housekeeping, for example, using variables in the input to the simulator, and show how one should structure the input to the simulator. Finally, we will perform basic post-processing, including video generation, snapshot generation, as well as some simple overall statistics of the DEM simulator's output. Let us first look at which different DEM simulators exist. What is the available DEM software? Let us therefore start with selected open source simulators, meaning that the computer code is openly available. There are many solutions, for example, Yade, Mercury DPM, LMGC90, which is a little bit a special case because it's not a SoftSphere DEM simulator. Then Lights is a very often used tool, and also MFix. If you don't want to install software and you just want to try out the DEM world, I would like to give you the hint to visit this website that allows you to use online simulators. Let's do this now and visit this website. If you do that, we arrive here at this beautiful page where you have a variety of simulations that are already set up for you. For example, this rotating bi-dispersed drum. If you click on that, you will arrive at this website. Here you can, for example, look at the motion of particles of different sizes in a rotating drum. You can change, of course, the speed of this drum, particle friction coefficients, filling fraction, size ratio. Also very nicely done here, you can look at the Eulerian fields, so the spatial average quantities. In this case, it would be the size, but you have many other options here. For example, you can also visualize the average velocities of the particles. Another nice example here is the so-called least average shear flow. You can here look at the flow. You can change again basic quantities. I don't want to do this now. And on the left hand side, you have a nice illustration of some statistics. For example, the average particle velocity as a function of the lateral distance here. You've seen it already before. We can make the particles here less opaque to visualize, for example, this contact network. This is also called the force chains that form in such a granular flow. Let us now go back to the presentation and have a brief look at commercial solutions. Again, here we have also a variety of mature tools, for example, Aspherics, XPS, Rocky, or DEM. To round up this part, let us have a look of what we can predict with this DEM software. For example, excavation processes or geophysical applications are in a very much focus of DEM simulations nowadays, and also particle handling. For example, you see here a model of a conveyor belt that will accelerate the particles from left to right and pour them into a box. Another application example is the design of chutes. Here you see such a chute and how the particles flow over the chute if you pour them on the chute. Last but not least, a more academic example is powder compaction. What you will see here is that a plate will compact this powder in a cavity. Powder cannot escape, of course, and the particles will start to move and compact. For now, we will use one of the open source simulators, which is LIGHTS. LIGHTS stands for LAMPS, Improved for General Granular and Granular Heat Transfer Simulations. LAMPS, you should know, is a well-known molecular dynamics simulator, and as you can see, the name implies already that the creators of LIGHTS were interested very much in multiphysics applications such as flow and heat transfer. That's it already for this introductory part of this unit. See you next time.